Scatter plots consist of points plotted on 2D mesh, made of two axes, say x and y. The data aren't connected with lines, thus they look scattered and unconnected. These plots are achieved by using the scatter function, which takes two arrays as arguments. Scatter plots are used to get correlation between two variables. When plotted, the cluster shows a strong correlation between particular data range. This is the one key action required for regression analysis. Many of you are aware if you have done some statistical analysis in your physical problems. Let us check this with an example on our Colab platform. As you can see here, I have written a simple Python code. This particular code, in this particular code, as you can see that I have taken two variables, x and y, and those are the random variables. It has 1000 number of points. I am going to generate the image which I have shown you in the slide. On running this particular code, as I already mentioned, scatter is used for plotting scatter plot. Let's see what we want to. Here x label and y label are used for labeling the plot, that is a graph. So this type of scatter plot is being generated. Since I have used random number, the plot changes each time I run this particular. There is always a variation in this. Okay, let's move to our next topic, that is pie chart. You are quite familiar with what is pie chart. That is no need to explain what this particular chart means. But just for clarification, when data need to be categorized into sectors for a number of events in a particular range, pie chart comes in handy. Pie charts are circular in shape where sectors or widths are carved out for different data range. The size of the wedge, or you can say a sector, is proportional to the data volume. So the pie function in Python in matplotlib pyplot is used for plotting pie chart. A similar example on Colab platform is been there. Just for understanding what this particular pie chart means, as you can see here, array has been created using NP array function. And now let us run this code. This is the thing when we have to see what is explode and why it is explode is required is one of the thing. Here the pie chart has been formed in this particular form. So when the explode label is not defined, is this particular label, if it is not defined, explode label is not defined, you get an unexploded pie chart. The unexploded pie chart by mean, let me show you. Pie chart, it is not divided, the sectors are not separate, they will be connected on each other in the center. But when there is an explode, the output will be in this manner. Okay, so we get an unexploded pie chart when an explode level is auto PCT, that is automatic. This particular sets the percentage of weight for a particular weight. The percentage of weight for a particular weight, which can be set by format specifier. So percentage 2.2 f. It sets the display of the percentage weight up to 2 decimal places, 2 significant digits shadow. This is the particular auto percentage PCT. Shadow provides the single digit. Is by shadow I mean it provides shadow belong to which so that it looks like a real time. 6.67% the sector will be put in that particular format. That is what I want to say. Moving further, the next part which we are going to discuss is polar plot. So, quite familiar one. We know about polar system. Until now, all the plots we have discussed have been dealing with data defined in cartridge. Okay, but what about data which is defined in the polar system? We know that polar system, instead of xy coordinates, there are r and theta coordinates. The polar plots are obtained by using the plot function. A certain example for it is written in this one for a polar plot. I have defined r from 0 to 10 with zero point 0.1 step size in a range. Theta is to 5r. Okay. The polar plot will be yield of polar. Polar function is used to understand this. And we will get a polar plot. You know what this particular graph. Okay. Now, moving further, we are going to talk about decorating the graph. What is a particular, how to decorate a graph. So, understanding a graph is quite different each and every time. You know, sometimes we require to put text at a specific place of the plot. Say at coordinate xy, I want particular text indicating that this particular is shown in this figure. That this point is at origin, or this point is at no. What is sine theta 0 at this particular value when sine comes up? I want to plot it. I want to write the function of the plot. At that time, decorating is required using text, using arrows, using annotations. So the text function is used to place text on the plot. In a similar manner, annotate function is used to place annotation. While using a text function, we require the xy coordinate of the plot. Okay. This is quite like the trial and error method. But if you know how you divide the plot, how you give a text to your plot, at that time, you can actually know that what this function can do. Let us check this example so you can understand it more clearly. I have written a simple example for demonstrating this one. This is quite a long bit of code, but if you check it clearly, that most of the time it has text function that is used to write. So here you can see I have arranged means x and y has been divided. Y is equal to sine theta sine x, and x is an array, or not an array, but you can say it is from range to 0 to 2 pi with step size of 0.01. Okay. We know that how to plot this particular function. So plot function is used to x, y, and the color will be red for plotting. The texts are at different level, that is 0.1 minus 0.4 something, and each and every text defines something that sine theta is equal to theta, actually 0, sine 0 0, sine 90 90, 180, what is the value. I also use annotate, and I also use title labeling for it. So the output will be similar to the one that is explained to you, shown you on the graph. As you can see, this particular value comes where x and y has been defined on the graph. You have to define the value of x coordinate and y coordinate to place this particular text. That is at 0.1 and minus 0.04. It will specifically keep this particular text. In a similar manner, a particular arrow can be kept using this annotate function. In this annotate function, if you do, I have written here the arrow props. The face color should be green. So arrow props is used to to an arrow. Okay, and it is synced to 0.05. The size, okay, is up to this, and xy text at 5 and 0.7. The size of the text is size 5.7, xy is 3 and 0.1, that is 3 and 0.1, here 3 and 0.1. This is the point. The output will be here, so the anode function will show the arrow by default here. This all has to be written. The scene, the text, the arrow, the annotation can be placed at appropriate places by defining coordinate axes point for them. Convenient method of identifying appropriate coordinates is to roll over the mouse on the body of the plot and look for the down left corner of the figure where present mount coordinates are shown. You can use this help function help.lib.pyplot.annotate. It gives you a useful information regarding this function. Okay, the next topic which we are going to discuss is about subplots. So subplots, that are multiple plots can be plotted using subplots. Yeah, you are well aware about this. If not, then you can clearly check it here. What actually a subplot means. So basically it looks like this. In a simple graph, a number of plot has been added. So subplot is nothing but this. In a simple, for explaining purposes, multiple plots can be plotted using subplot option, where different plots are considered to be a matrix of a graph. Just like a regular matrix, elements are identified by indices, okay, index numbers. So subplots are located using indexes like 2, 2, 2, that is 2 by 2 matrix, and second number, and one is accessing a second position of the place. For example, the scatter plot which I have placed here in this figure is 2, 2, 2. If it is for 2, 2, 1, the first position, 2, 2, 3 is the third position, 2, 2, 4 is the fourth position. The first two values shows the size of the matrix, and the third value shows the position of the graph. In this particular example which I am showing you, I have plotted similar four type of graphs or plots using subplot in a simple one figure. Okay, at as I was on, subplot is used. 2 to 1, I am adding a simple plot. In 2 to 2 a scatter, in 2 to 3 a histogram, and 2 to 4 a bar, horizontal bar graph. And the output which you can see is flux. Axis and everything could be arranged in the manner. If you go through different research articles, you have seen this type of plots, and that's why it is said that Python plots are article ready plot. The next particular code is for saving a plot file. How to save? A savefig function is used to save a particular image file, and if you run this code, I know in this import function will not show you on Google Colab platform, but if you are running on Anaconda IDE or IPython console IDE platform or Spider IDE platform, simple Python platform, ideally, when you run this particular code and whenever you write savefig function, a particular plot will be saved with the name and extension which you have given it. So most of the time, whenever you're using plot, the matplotlib needs to be saved, the graph needs to be saved for future references also, and at that time savefig function is used with a specific file name, permission, file type, and so on for the figure. So this is one of the example, but I know if I'm going to run it, it is not going to save it here. It will just show you the figure. But if you run this particular code over your system, personal system, not on cloud platform, you can know it. By default, it will save the figure plot1.png over a working folder. If provided a proper path with a string, the argument savefig function file is created at a path provided by you if proper privileges has been given and created at the same time. Uh, it is also important to know the size of the plot, the size of the file, the resolution of the file is very much important for us. So if you are aware that many of the how can I explain it, that in many of the, for example, when you are applying for different exams, sorry just a minute. Sorry for earlier disturbance. Okay, I was at this point that many of the time you need to know the resolution of the picture, the resolution and the size of the picture. Even when you apply for some competitive exam, it is one of the required parameters that your size of your image should be in this particular format, in this XY size, and the resolution of the image. So this particular thing also is important when you go for publication. It is important to know the size of the file and the resolution of the figure for the purpose of publication at both offline, or that is a print mode, or online medium. When none of the arguments for setting the resolution of the figure and size of the file are set within the program. Okay, when none of the arguments, there are no particular arguments, the default values are used actually. Um, for example, in this particular example code, I have just shown you this. As you can see, I am using RC parameter function for knowing the figure size. Okay, so currently it will work and it give me the resolution of 72 for this particular size DPI. So if a particular file size is available, if the particular figure is available, then yes, it will show you the particular figure size, 8x6 or 8 by 6 inches. Currently it is in cloud platform and I haven't given any figure size, figure number name. So at that time, and in this particular code, it will show me only the default resolution of this particular figure. If it has been saved, it is 72.0. Okay. In actual scenario, a figure size will show you the figure size such as 8x6. If you have a particular figure with you, you can write figure name dot figure size and it will show you the size. Similarly, if you want to know DPI, so it will show you the resolution of that image. Since if I run this code on my analog ID, then it will show me a 8 by 6 inch figure is created with 100 DPI image using savefig function. Okay, the length and units are ignored and the pixels are displayed actually. If the file is directed towards a printing media like a printer or plotter, length of the parameter and DPI is important, figure size and resolution. Okay. So this is the important part about one important savefig function. The next important thing which I would like to show you is the working with matplotlib as in object mode. Okay, there is a very much difference up till now what we have done and what is actually an object. The Pythonic way of using matplotlib is to use it in object mode, where explicit definition of an object allows ultimate customization. For this purpose, we must define each element of a graph as an object and use the properties to customize the same. Okay, the hierarchy of the three basic objects used for the purpose are as follows. The first one is figure canvas. Figure canvas is container class for figure instance. Okay, the figure is the next one is figure, which is a container class for axis instance, and the third one is axis, that is the rectangular area that hold various plot features. Okay, when you work with matplotlib in object oriented mode, we specify a figure canvas which holds a figure that in turn holds the axis. Okay, this is the hierarchical manner. There is a canvas in which a figure has been holded. The canvas will contain a figure. It's similar to your canvas which hold your photo, and the figure by itself holds the axis, where a variety of plotting features can be implemented. The whole procedure allows customization of any extent that can be imagined. Okay, this is the object mode which I'm talking about. So if in this particular example, if you can see the next line of codes here, so I have just written a random code for demonstration purpose only. If run line to line, here it is run in a single starter. If run line to line, you can see that how you can change this particular axis step by step. In your code, you directly run this command, directly run this code, and on IDE platform and editor, and you can see how the canvas holds the figures instance fig that adds upload. The fig stores the figure instance, and each time when you run the fig, even if it is backward, it will show you the result at the same place. This is just a simple demonstration for explaining the concept of it. So next we are going to move on logarithmic plots. We know a variety of engineering data use logarithmic scale, particularly those where change in results in an order of magnitude change in a value of observed variable. Python provides a facility to plot logarithmic plots. Okay, so it is quite easier, but in that logarithmic plots you have to have y-axis, or particular one axis must be in log mode. For demonstration purpose, here a demo code has been written, and you can see here x has been divided from 0 to 10 with a step size of 0.01, which has been plotted. Then a simple y1 is log of x, y is nothing but log of x. There is also y2, which is a simple sine function pi x by 2, that is pi theta by 2. That is second axis, the subplot. I use subplot in this. Y3 is n pi x3, pi by 3, pi theta by 2. And pi 4 is cos 2 theta. Let's see how this particular logarithmic plots. Example. This is just for example purpose. Okay. I have used number of functions to show it. And you can see on log scale axis. Okay, this type of variation will occur. So as seen from this particular program, logarithm value can be directly plotted using plot function. It doesn't require any particular different type of code. But in this particular example, in each and every example, if you have noted, I have used log, semi log x, log, and functions. So when a particular axis is needed to be plotted in logarithmic values, we use semilog and semilog y functions, where a base in the index can be also defined. Okay, either it is base 10, base 2, or natural number. The value of that particular axis is converted into logarithmic scale and plotted subsequently. When the logarithm value needed to be plotted on both axes, we use log function. Logarithmic plots find their use in a variety of fields like signal processing, thermodynamics, even in air quality analysis also, when we do mass concentration and particle concentration, number concentration. Eventually, whenever data changes in order of magnitude, it is easier to observe it using a logarithmic plot. A logarithmic scale is a non-linear scale. The ability to change the base of a logarithmic function provides a powerful tool at the hands of developers to derive the most meaningful conclusion. I hope it is understandable. Moving further to our next topic, I missed to change. Okay. The logarithm we have covered. Two plots on same figure with at least one axis different. Okay, this is the particular case which I want to explain. And here we use a different function called twinx to understand. So function twinx and twiny can be used for two x-axis and y-axis on the same figure to plot two set of data points. For example, here we have used twinx and it is going to in the x-axis produce plots of two data sets sharing the same x-axis data points. Okay, as I am showing you, it is quite easy to understand this code, and it is quite easy now. I'm quite sure that you are familiar with Pythonian way of writing code. Okay, when you run this code, and you can see that there are two x-axis, one is here, one is there in this particular direction. So you can plot it is in this manner using twin xy. Similarly, you can do for y-axis. It is worth noting that the two different axis instances, namely for example ax1 and ax2, are superimposed on each other, where data from y1 being allotted to axis ax1 and data from y2 being allotted to axis ax2. This also illustrates the power of defining a plot in an object mode. Okay, this particular using twinx. You can also go for twin y. Okay, moving to our next topic, that is about contour plots. Okay. If you have seen this code for twinx1, I just forgot to change this slide. Let me show you again. It is like this. This particular code shows the use of twinx to plot in both axes having 2x or 2y's, and the output will be this. The function is used here twinx, so it will twin the x-axis, that is ax1 and ax2. We have used ax1 for plotting y1 and ax2 for plotting y2, and so the differences will show. Okay. Now moving further, we will go for contour plots. So in some engineering applications, contour plots become an essential part of interpretation because they can define segregation of data into regions based on certain similarities. For example, if you imagine a mountain view from the top, you can define regions of similar height being shown in a close loop. Thus, a mountain will be a series of loops. Okay. Similarly, a 2D map of a non-uniformly heated region can be viewed as contour, depicting regions of same temperature. A region of rainfall can be viewed as contour, showing regions of dissimilar size of droplets. Hence, contour lines are also called level lines or ISO lines. The term ISO is attached to data points having constant values, and the region of these data points are separated by contours. They are separated by contours. That is why. For a contour plot, you need three axes, that is x, y, and z axis, where z axis defines the height. The data with the same height is clubbed together within ISO lines. Simple example has been demonstrated here. If you go to, you have to just run in the left platform. Here I've used linear spaced x and y from between 0 to 1 with 100 steps, and y between 1 to 2. I've used mesh grip and z to indicate the size, that is the height. Okay, so np.sin x and np.sin y is the difference between sin x, sin of x, and sin, and I'm going to plot it. Contour function is used to plot a contour graph. Similarly, I have also used plotting a filled contour and unfilled contour. There are two outputs. When you plot on running this code, one of the output will be filled and one of the output will be empty. Okay, as you can see here, this contour lines. It's quite simple to have this type of plots. Okay. The contour and contour f function can be used to plot unfilled and filled contour, as I have demonstrated in this example. A simple command like help in bracket contour gives you an extensive information about setting various parameters of contour plot. I hope you all go with this help function and explore each and every function that is